Welcome back to Astronomy Daily. I'm Anna.
And I'm Avery. And Anna, can I just say, it is so good to be back on air.
It really is. We've had a short break in production, but space? Space did not take a break. In fact, the cosmos has been absolutely firing this week, and we have got a packed episode to prove it.
We are talking black hole stars finally confirmed, a rocket that hasn't flown in a year and a half roaring back to life, the next generation of space exploration hardware arriving at Kennedy, and, just a small update about the eventual fate of the entire universe.
No big deal, just the end of everything.
We'll also have some gorgeous skywatching news for our Southern Hemisphere listeners. A meteor shower is peaking in just days, and it is a good one.
This is Astronomy Daily, Season 5, Episode 93, and we are absolutely delighted to be back. Let's get into it.
All right, we are starting with what might honestly be the biggest cosmological story of 2026 so far. It concerns those mysterious little red dots that James Webb has been teasing us with for the past couple of years. And this week, NASA's Chandra X-ray Observatory may have finally cracked the case.
For anyone who needs a quick refresher, ever since Webb started its deep sky observations, it kept finding these strange, compact, ruby red objects scattered across the early universe. They existed when the cosmos was only a few 100 million years old. They were too massive to be ordinary galaxies, but they weren't behaving like the supermassive black holes we know either.
And critically, they weren't emitting X-rays, which is really weird because actively feeding black holes almost always do. So what were they?
Well, this week, Chandra found an X-ray signal that lines up precisely with the position of one of Webb's little red dots. The object, cataloged as 3JWST-AGEIS 12014, had been sitting in Chandra's database for years, but it only became significant when Webb imaged the same patch of sky and found a little red dot in exactly the same spot.
And that X-ray energy, it matches the signature of a quasar, a galaxy powered by an extremely active black hole. This is the first little red dot ever observed in X-rays, and it gives astronomers their strongest evidence yet for what these things actually are.
So the leading theory, which is gaining serious momentum now, is that little red dots are so-called black hole stars. Picture a dense cloud of gas, perhaps a few hundred light years across, with a growing supermassive black hole eating it from the inside out. The heat from that infalling material glows, not as X-rays, which get absorbed by the surrounding cloud, but as visible red light, which is exactly what Webb sees.
It's a completely new class of cosmic object. Not quite a star, not quite a galaxy, something in between. An early universe state we've never directly observed before.
And if this interpretation holds, it helps solve one of the biggest puzzles in modern cosmology. How did supermassive black holes get so enormous so fast? The answer, it seems, is that they grew inside these massive gas cocoons, hidden from our instruments, consuming their birth clouds from within.
One astronomer told Scientific American, and I love this quote, "LRDs once seemed to demand either impossibly efficient galaxy formation or implausibly massive black holes appearing out of nowhere. Either way, something was badly wrong with our models. But now, the pieces are fitting together."
More X-ray follow-up and more Webb spectra are needed to confirm the picture fully, but the community is buzzing. These objects may be Webb's single most consequential discovery yet.
The universe really does reward patience. Sometimes you just have to wait for the right telescope to look in the right direction.
Now, for our regular listeners, you'll know we've been following the Artemis story closely across this entire season. Artemis II launched on April 1st, took 4 astronauts on a breathtaking journey around the far side of the moon, and splashed down safely on April 10th. And this week, there were 2 remarkable developments happening almost simultaneously at the very same spaceport.
It really was a full-circle moment in Kennedy Space Center on April 28th. On one side of the facility, the Orion capsule, named Integrity, the very spacecraft that carried Wiseman, Glover, Koch, and Hansen around the moon, arrived back home for post-flight analysis.
Engineers are now in the process of deservicing Integrity. removing payloads, extracting avionics boxes for reuse, and conducting detailed scans of the heat shield and other systems. Every piece of data they recover will directly inform Artemis III.
And at the very same time, on the other side of Kennedy, the core stage for Artemis III's Space Launch System rocket was being offloaded from NASA's Pegasus barge and moved into the Vehicle Assembly Building. That core stage, the largest structural component of the rocket, had been manufactured at NASA's Michaud Assembly Facility in New Orleans and shipped 900 miles by sea.
At 212 feet tall when fully assembled, the SLS core stage is an engineering marvel in its own right. It houses 2 propellant tanks holding over 733,000 gallons of super-chilled liquid propellant, enough to power 4 RS-25 engines for more than 8 minutes of flight.
And this marks a first for the program. For Artemis I and II, the entire core stage was assembled at Michaud before shipping. Starting with Artemis III, NASA and Boeing are splitting production, outfitting major sections individually and joining them at Kennedy. It's a streamlining of the manufacturing process designed to accelerate the cadence of future missions.
Artemis III is currently scheduled for launch in 2027, and it'll take astronauts to Earth orbit to test rendezvous and docking with commercial spacecraft, the critical step needed before Artemis IV can actually land humans on the lunar surface in 2028.
The pace of this program right now is genuinely impressive. Artemis II just came home, and already the next mission's rocket is being assembled. That's how you build momentum.
Now, let's talk about a rocket comeback, because on April 29th, SpaceX's Falcon Heavy roared back to life for the first time in 18 months, and it did not disappoint.
18 months. For a rocket of that capability, that is a long time between flights. The last Falcon Heavy mission was in October 2024, when it launched NASA's Europa Clipper toward Jupiter, and now it's back.
The mission was Viasat-3 F3. The third and final satellite in Viasat's constellation of high-capacity broadband relay stations. This 6.6-ton spacecraft is headed for geostationary orbit, where it will serve the Asia-Pacific region with more than 1 terabit per second of internet capacity. It completes a constellation that Viasat has been building for over a decade.
And Falcon Heavy delivered in spectacular fashion. Liftoff was at 10:13 a.m. Eastern Time from Launch Complex 39A at Kennedy Space Center, the very same historic pad that launched the Apollo missions. And the rocket's 27 Merlin engines generated 5.1 million pound lift thrust at liftoff. The sight of that thing climbing into the Florida sky is always extraordinary.
But perhaps the most crowd-pleasing moment came about 8 minutes after launch, when the 2 side boosters, veterans of previous flights, executed simultaneous touchdowns back at Cape Canaveral Space Force Station. Those twin sonic booms, those 2 columns of fire landing in perfect formation, it never gets old.
The central core booster was not recovered on this mission. It was expended as planned and came down in the Atlantic. But with 2 reusable side boosters safely home and the satellite deployed successfully a few hours after launch, it was mission accomplished.
This was the 12th flight of a Falcon Heavy since its debut in 2018. While Falcon Heavy doesn't fly as often as its Falcon 9 sibling, in a way, it's a victim of the Falcon 9's incredible versatility. When it does fly, it's always an event. And for Viasat, it was the completion of something they've been working toward for more than 10 years.
The Viasat-3 program has had its share of challenges. The first satellite had an antenna deployment issue that crippled most of its capability. But the constellation is now complete, and Viasat is looking ahead. Welcome back, Falcon Heavy.
All right, now for what might be the most mind-bending story of the week. How comfortable are you with the concept of the universe ending?
Oh, extremely comfortable. It's fine. Everything is fine.
Great, because a new cosmological study has just suggested that the universe may be on a much tighter schedule than we previously thought. We're talking a potential big crunch, a total cosmic collapse in just 33.3 billion years.
Now, to be clear, that is still an almost incomprehensibly long time. The universe is currently about 13.8 billion years old. We're talking about more than twice that again before anything dramatic happens. But in cosmological terms, this represents a serious revision.
Up until recently, the dominant view was that the universe would expand forever, driven by dark energy, that mysterious force which makes up about 70% of the universe's total energy content. Galaxies would drift further and further apart over trillions of years, leaving a cold, dark, empty cosmos.
But this new research, published this week, and using real observational data from two of the world's most powerful cosmic surveys, the Dark Energy Survey and the Dark Energy Spectroscopic Instrument, introduces a different possibility.
The key is something called the Axion Dark Energy Model. It's a hybrid theory that treats dark energy not as a fixed constant, but as something that can evolve over time, specifically as a combination of the cosmological constant and an ultra-light particle called an axion, which is usually associated with dark matter research.
And when researchers tested this model against real galaxy survey data, we're talking maps of hundreds of millions of galaxies. It fit remarkably well. More importantly, it predicts a future phase where the combined effects of this axion field begin to pull the universe inward rather than push it outward.
So instead of eternal expansion, you get a universe that reaches a maximum size, slows, stops, and then begins to contract. Over billions of years, galaxies that are currently racing apart would begin to draw closer. Cosmic structures would compress, temperatures would rise, and ultimately, everything would collapse back into an ultra-dense state, a big crunch, mirroring the conditions of the Big Bang in reverse.
There's even speculation that such a collapse could trigger another cosmic cycle, a new Big Bang from the wreckage of the old universe, which is either terrifying or poetic depending on your perspective.
Now, it's important to say this is one model among several. The fate of the universe is genuinely one of the open frontiers of cosmology. But what makes this significant is that it's grounded in actual observational data, not just theory, and it highlights just how much the behavior of dark energy matters. Even small changes in how it acts over time lead to completely different ultimate destinies for the cosmos.
It also gives us a really compelling reason to build the next generation of space observatories, including, as we covered recently, the Roman Space Telescope launching in September. More data, better models, clearer picture of what actually awaits everything that exists.
For now, enjoy the stars. You've got 33 billion years and change.
Plenty of time.
As we mentioned earlier, Artemis II's Orion capsule is now back at Kennedy Space Center. And while engineers are thrilled with the overall success of that mission, 10 days in space, humans around the moon for the first time in over 50 years, it wouldn't be a test flight without some things to learn from.
And mission managers have been admirably transparent about what they found. Following splashdown on April 10th, several issues were flagged for investigation, and NASA's post-mission briefings have given us a clear picture of what comes next.
The big one everyone's watching is the Orion heat shield. Made from a material called avcot, the same ablative material used in the Apollo era, the shield performed well during the fiery re-entry at nearly 24,000 miles per hour. But there were expected signs of divots and cracking in the material.
This was anticipated. The heat shield's behavior during re-entry has been a known discussion point since Artemis I. What's different now is that engineers have real-world performance data to analyze, including detailed scans and imagery from aircraft that tracked the capsule during re-entry. The data is now being processed at Kennedy.
Beyond the heat shield, mission managers identified a valve in Orion's service module that requires a redesign, and in perhaps the most relatable moment of the entire post-mission debrief, there was a toilet issue that needs to be sorted out for future long-duration missions.
To his credit, Artemis II Commander Reed Weissman has defended the mission's facilities, saying, and this is a real quote, "That was a wonderful toilet. So make of that what you will."
NASA's Associate Administrator for Human Spaceflight acknowledged that these issues represent a tight turnaround for Artemis III, scheduled for 2027. But importantly, the agency says it is learning to move faster, and the overall vehicle performance was strong.
The design changes for the heat shield will be implemented for Artemis III. The AFCOT permeability issues that cause the erosion pattern are understood, and the revised design is already in development. These are the growing pains of a new crewed lunar program, and NASA is working through them systematically.
The key takeaway: Artemis II achieved all its primary mission objectives, the crew came home safely, and the data collected is now directly shaping the next mission. That is exactly how test flights are supposed to work.
And now for something you can actually go outside and experience yourself, because one of the best meteor showers of the year is peaking in just a matter of days. We're talking about the Eta Aquarids.
The Eta Aquarids peak around May 6th, so that's just days away. And this is an especially exciting shower for our listeners in Australia, New Zealand, and across the Southern Hemisphere. You're in the prime seats for this one.
So what makes the Eta Aquariid special? These meteors are debris from Halley's Comet. Every year, Earth passes through the trail of dust and particles that Halley left behind on its journeys through the inner solar system. Those particles, some no bigger than a grain of sand, slam into our atmosphere at about 40 miles per hour and burn up in brilliant streaks of light.
Halley's Comet last passed through the inner solar system in 1986 and won't return until 2061. But every year, we get to pass through its legacy, and the Eta Aquariids are that legacy made visible.
At peak, you can expect up to 50 meteors per hour under good conditions, and the Southern Hemisphere gets significantly more activity than the North because the radiant point, in the constellation Aquarius, sits higher in the southern sky.
The best time to look is in the hours before dawn, roughly between 3 a.m. and first light. Get away from city lights if you can, let your eyes adjust to the dark for about 20 minutes, and look toward the northeast. No telescope needed. This is a naked eye event.
One thing to note this year, the moon may throw some light into the sky in your peak, which can wash out the fainter meteors. But even so, the brighter Eta Aquarids, particularly those long, graceful streaks that leave glowing trains across the sky, should be spectacular.
These fast-moving meteors are famous for leaving persistent trains, glowing trails that can linger for several seconds after the meteor itself has gone. They are some of the most photogenic meteors you'll see all year.
So, Southern Hemisphere friends, set that alarm, grab a blanket and a thermos of something warm, and go say hello to the ghost of Halley's Comet. It's waiting for you.
What a week to come back to. Black hole stars, moon rockets, Falcon Heavy, the potential end of the universe. Honestly, space is just never boring.
Never boring, Anna. Never boring. Thank you so much for joining us for Season 5, Episode 93 of Astronomy Daily. It's wonderful to be back.
If you want to go deeper on any of today's stories or check back through our archive from across the season, you can find everything at astronomydaily.io. And if you're enjoying the show, please do leave us a review or subscribe wherever you get your podcasts. It genuinely makes a difference.
You can also find us on social media at @AstroDailyPod, and we'd love to hear from you if you go out and catch the Eta Aquarids this week. Share your meteor photos. Tell us what you saw.
Until next time, keep looking up.
Clear skies, everyone. This has been Astronomy Daily.